In this question, they're asking to find the net force and torque on a dipole in uniform electric field. Again, for what orientation is the torque? Maximum, minimum, and half the maximum. After that, what would happen if the field is non-uniform? Specifically, the electric field intensity is increasing parallel to dipole moment in the non-uniform case and anti-parallel to dipole moment. So we'll check uniform electric field case as number 1. In uniform electric field, the electric field lines are parallel, equidistant, represented by the black color. Electric field is always directed from positive to negative. Since it's uniform field, the strength of the field is same everywhere in the region and the value is E. The dipole with minus Q at A plus Q at B, dipole moment is always directed from negative to positive by convention. P, it's making an angle theta with the direction of electric field. Now, if you check the force on the positive charge, it is QE. It will be attracted by the negative part, so parallel to the electric field. Force on the minus Q, the field and charge remain same. Since this negative Q will be attracted towards positive. So same magnitude on the negative charge, but this anti-parallel to the electric field. So a system with equal force, opposite direction. So the net force should be QE minus QE is 0. So if you calculate the torque from the dipole, torque is R cross F. R is AB, F is QE. So AB cross QE. AB is the dipole length. Dipole length is represented as 2A. 2A times the force QE. 2A into Q is P. Will be P cross E. So torque is P cross E. It's a vector form of the torque. If you check the magnitude, expanding P cross E will be just P sin theta. So there's a net force and net torque on the dipole in uniform electric field. So now we need to check when the torque is maximum. Maximum when sin theta is maximum, theta is 90 degrees. That means dipole and field are normal to each other. Maximum torque will be P sin 90, which is P. Electric field and dipole moment are aligned perpendicular to each other. Now the minimum will be the 0 torque. So that sin theta should be 0. Theta can be either 0 or 180 degree. So one case, dipole moment is parallel to the electric field. And second case, dipole moment is anti-parallel to the electric field. Both cases, sin theta will be 0. The torque on the dipole will be 0. Now, half of the maximum. P and E don't change, only the angle is changing. So sin 30 only half. So torque will be half of the maximum value. When sin theta become half, sin theta become half for 30. So these are the cases where we discuss torque and force on the dipole in uniform field. Now we need to go for force and torque. What about in non-uniform electric field? So in a non-uniform electric field, the strength and the direction of the field may be different in different direction. So they given the strength is increasing parallel to the dipole moment. So if you see a diagram, dipole moment is from minus 2 plus. These lines are far apart representing weak field at E1. The lines are close at E2, representing a strong field. So the force on minus Q will be towards the positive side, be QE1 to the left. And force on the plus Q of the dipole is towards the right, QE2, because of the positive polarity here. Since E2 is stronger, QE2 will be greater than QE1. So E2 is greater, E1 is less. That means QE1 is less, QE2 is greater. So the net force magnitude will be greater force minus smaller force, QE2 minus QE1. The direction of the force is along the direction of the greater force. Greater force is QE2. That is parallel to the dipole moment. So the dipole will undergo a translatory motion along the direction of the net force, which is parallel to the dipole moment. Now, dipole in non-uniform electric field, where electric field is increasing anti-parallel to the dipole moment. So this is minus 2 plus Q, the dipole moment. Electric field is, direction is towards the right, but strength is increasing anti-parallel. So here weak, and it's increasing and becoming stronger in the opposite direction of the dipole moment. If you check, force on minus Q still be towards the plus side, QE1. Force on plus Q to the positive side, negative side, QE2. And this field is weak because the lines are far apart. So weak force, strong field, strong force. So E1 is greater compared to E2. So automatically QE1 becomes greater than QE2. So net force will be greater force minus smaller force, QE1 minus QE2. Even the direction of the net force will be along the direction of the greater force. That will be towards left, which is anti-parallel to dipole moment. So the dipole undergo translatory motion anti-parallel to the dipole moment. This is the force case. If you check the torque, all these cases, all this means these two cases where the dipole is aligned parallel and anti-parallel, that particular case, the torque on the dipole is P sin 0 or 180. So both cases, the torque will be 0. 0 or 180 degrees possible. Yeah, so torque will be 0 if the dipole is parallel, means 0 degree or anti-parallel to the electric field. All other cases, dipole experience a non-zero torque. So the torque case, whether it's field uniform or non-uniform, it is 0 only when the dipole is aligned parallel or anti-parallel. All other cases, torque will be non-zero.